The butterfly effect is a metaphor that illustrates how the tiniest change in initial conditions within a complex system can lead to fundamentally different outcomes. The term was popularized by meteorologist Edward Lorenz during the 1960s and 1970s. In one of his presentations, he asked the provocative question, "Could a butterfly flap its wings in Brazil and cause a tornado in Texas?" Though this image is figurative, it encapsulates the core of the phenomenon. Systems subject to chaotic behavior are highly sensitive to initial conditions. Even minimal deviations can, with time, grow into large-scale and unpredictable transformation. Because of its vivid metaphorical nature, the butterfly effect has made its way into literature. One famous example is Ray Bradbury's short story, A Sound of Thunder, 1952, where a time traveler accidentally steps on a butterfly in the distant past, triggering a radically changed future. The English language is different, and the United States is ruled by a dictator. There are many domains where the butterfly effect can be observed, from economics to personal life. In 1996, a rocket of the European Space Agency, Ariane 5, failed because of a software error. A minor problem in converting a 64-bit number into a 16-bit integer caused a cascade of computational errors and led to destruction of the rocket. In 2010, the Dow Jones Index dropped nearly 1,000 points within minutes, a so-called flash crash. Investigations showed that a chain of algorithmic trading bots triggered by an anomaly in volume led to a cascading sell-off. The term's origin lies in studies of sensitivity of systems to initial conditions within mathematics and physics. In 1963, Lorenz ran simulations of atmospheric processes using a set of numbers for a weather forecast model. When he restarted the simulation, he rounded one of the input values from 0.506127 to 0.506, a difference of less than 0.02%. And yet days later, the simulated results diverged radically from the original. In 1972, Lorenz delivered a talk titled, "Predictability. Does the flap of a butterfly's wings in Brazil set off a tornado in Texas?" It was the moment the butterfly effect term entered wider circulation. Popular magazines such as Scientific American and New Scientist helped spread the idea in accessible form. In theory, the butterfly effect is central to chaos theory, a branch of mathematics and physics concerned with dynamic systems that are highly sensitive to initial states. The effect shows how very small changes can lead to huge consequences. The chaotic nature of many systems, climatic, biological, economic, makes their outcomes very hard to predict. In psychology, the butterfly effect appears in how tiny events can shape a person's life. For example, childhood traumas. A seemingly innocuous remark by a parent can affect self-esteem over decades. Another example is first impressions. A random encounter might lead to a lifelong career change. Therapists sometimes use the butterfly effect concept to help clients recognize that even small positive changes in habits can lead to major improvements in emotional and mental well-being. Does the butterfly effect truly exist? In 2019, researchers at Los Alamos National Laboratory used an IBM quantum computer to simulate changes over time. They found that in quantum systems, the butterfly effect does not always apply. Some transformations are reversible. Many argue that the classical butterfly effect is a simplification, a metaphor that captures the core meaning of complex nonlinear processes. Others point out that even if precise prediction of events is impossible, understanding the sensitivity of systems is vital for developing adequate models of complex phenomena. Importantly, the concept has influenced not only physics and mathematics but also philosophy of science, economics, biology, and psychology. Its interdisciplinary reach allows us to view the phenomenon in a wider pattern. When systems are large, complex, and interconnected, behavior can become unpredictable.